Go ahead and go live. Okay, hello everyone. Well, I'm going to do something slightly peculiar today. As people might remember, I worked a bunch on combinators in preparation for their 100th anniversary on December 7th of last year. And I produced so much material that it has to be turned into a book. And so for that book, I'm planning to have a bibliography of combinators. And so what I was doing was assembling that bibliography, and I'm about to look through. I put all these papers in a bunch of categories, and some good people here have been adding in all sorts of abstracts for these papers. And my goal is to go through this list and find out if I put the papers in the right categories, and to find pull quotes from the abstracts, so that we can give an indication of what's going on without spending 100 pages on these abstracts. Okay. Wait a minute. Why is this found description in English? Okay. Well, this is the original paper by Schoenfinkel, and I know I have a version of that. Some of the relevant stuff in my let me see here. This particular one, I think we can probably get out of what I've written. Let's see. Let's see. I think there's a pretty good quote. See, I'm this process of trying to oh dear. Well, this is going to be one of the more difficult ones, but this isn't the right thing for this. Is this going to work? All these proxy links here? Yes, maybe. Oh, but do I have to download the PDF, or did you already download that?
The PDF is downloaded in the folder called Foundational Documents.
Okay. But I also have the translation of this, right, which I had from long ago, and that's the German version there, right?
Yes, that's the original.
Okay, so I had a version of that as part of the project. We had a version of that in English. And gosh, we've got, how many papers we have to go through here? 900 or something. So we got to speed up quite a bit. Okay, hold on. Let me see if I can get at least this one. I think it is in, is it in Schoenfinkel material, publications? Yeah, here we go. Building blocks of mathematical logic. Okay, here we go. So this is his original paper, and let's see. Oh my gosh, where is this? Okay, so I claim that is a So that would be our pull quote. I don't know why okay, so it's a little confusing, but I think let's keep going here. Okay, so this is his abstract, Curry's abstract, right?
For that particular paper, that was actually just a paragraph from the paper. He didn't have an official abstract, I believe.
Okay. Oh gosh, these are so turgid. These are really hard to read. Let's keep going and okay, this is not relevant. I don't know how we ended up with the Gödel paper in here. This is not relevant. I don't know why. Why is this here? Do we know?
But we discussed in a meeting that Jeremy has found these when he was looking for permissions, and you said that we should add it in.
Oh, it's totally wrong.
Okay, I'll remove it, or you can. Yeah.
I just removed it. Okay. So Quine, reinterpretation of Schoenfinkel's logical operators. Boy, this is hard to do, to summarize these things. Well, let's keep going and see whether it gets any easier. Okay, this is totally irrelevant. And why is that 1964? He wrote that in 1870. Where did this come from? It's just totally irrelevant. Where did this come from?
That source was listed in your original list, but it's possible we got the year wrong and maybe put the year of when it was reprinted.
Okay.
I can check it.
Okay.
Oh, I'm sorry. No, that was another one that you said we should add because we were finding it when we were sourcing images. You don't want that one in at all?
No, not at all.
Okay.
Not relevant. Okay. Here we go to this one. All right. Well, let's keep going here. I mean, this is... I don't think this is correct that these, I mean, the foundational documents, okay. Let's take a look at how this is being structured here. So, okay, so where did that abstract come from? Is
Which
that
abstract
also
are we looking at right now?
Curry and Fay's combinatory logic?
That one I believe is a description of the book because it's a
Okay.
book rather than a paper.
Okay. Well, so this says the revised edition. No, I mean, obviously that can't be the right thing because that's saying something about it's the revised edition. So, and is that the original version from 1981? I don't believe so. Right. So to get the dates right, we have to have the original version. I'm pretty sure it's much earlier than that. Revised second edition, no, that's not right. Can we find out what when the original was?
I can look for it, yeah. It seems that was the only version that we were able to find, but I'll keep digging.
I mean, I have a copy of the original. I could go get it, but I don't think it's 1981. But I might be wrong. Maybe I'm wrong. Oh boy. And where is? Oh boy. Okay, well, let's just keep scrolling through this and take a look at what we've got here and see whether this is making it more difficult to understand rather than less. wait a minute, this is a copy of this one. So we have to decide, this is called overviews and this is called surveys and summaries. So what's the difference between those? Oh boy. Okay. Well, let's see. Maybe we want to combine those sections. So I assume when it says and Bunda himself, do we did follow that link, so we have whatever that was pointing to, or not?
I'm sorry, can you repeat the question?
Well, no, let's not bother. Okay. Oh boy. Okay. For example, whatever that is. So, I mean, okay, what are we doing with this? Because there are individual papers in this book that talk about combinators. Do we think we picked those papers up separately somewhere or not?
Not all of them, I wouldn't think, because I didn't specifically go through and do that. I can't.
No, I understand that, but when you look at like Web of Science, is it separately picking up those things or not? Do you understand what I'm asking?
No, I don't. I'm sorry.
Okay. When you do a search for a title of a paper, is it including papers in a collection like this or not?
If you do a search for the title of the paper, it usually just gives you the paper. If you do a search for the title of the book, it will tell you all the papers in it.
I understand that, but I'm asking, if you search for the title, will it find a paper that is in this book? Or will it only find the whole book? Because if it found the papers, then we should have found these papers and listed them separately.
I think there are listings separately from that book later on in the list, if I remember correctly.
All right, fine. Okay, well, let's keep scanning through this. So some of these we don't have abstracts for. Okay.
Yes, there's very few that we weren't able to get any type of description. But for example, that one, we had to put in a request to the library and there's nothing really available for it online.
Okay. Oh boy. Okay. So we go from 1937 of Alan Turing to 1971. Really? It's possible. All right, maybe what I should try to do is this. Just try to figure out which of these don't belong at all, because I mean, this, for example, it's very specific pages. For goodness sake, that's certainly not what we want here.
Yeah, so we weren't sure which specific pages you wanted. So we put in the comments above that a couple of things that we thought you might have meant, but we wanted to confirm with you.
Okay, all right, okay. See what I'm thinking about here. Okay, when there's a whole book, humph, maybe we should just make, I'm still very confused what to do. We've got, we got early things. I'm just surprised there isn't more stuff from the 1940s and 1950s, because what you're showing here is immediately jumping to stuff. How can that be right? How can that be right? He wasn't even alive by then, was he? How can that be right? That wasn't the original version of that book, was it? No, it wasn't. Well, at least according to Wikipedia, it was published in 1985. That sounds like about the right time to me. Do you see what I'm saying? And that's the wrong publisher. I mean, it was published by Knopf in 1985. And the point is that we're trying to give people, the idea of the historical flow of this thing, right? So I guess it was republished by those guys. Okay, certain properties of Schoenfinkel-Curry combinators. Oh boy. That's not what I thought it was. That's not. By the way, do we think we saved that one already, or is that? Do I have to go look?
Which one?
This one, Kuzachev.
I don't think, being that one has the purple UIUC request number, I don't think we have it yet.
Ah, okay. So then this is merely the abstract that you already gave there.
Yeah, actually, in that case, that's a review of the book, which sometimes we used in place of abstracts if we couldn't find
Oh, no,
an
not a
abstract.
book. It's not a book.
Oh, the paper, sorry.
Right. Okay, this is a different thing. This one is actually about, and by the way, it's a shame we didn't manage to collect these in cell groups, which I didn't ask for, I know, so I get what I asked for. This should be in the section on combinatory logic. And that was what date? That was 1980 something, right? Ah, I got it in the wrong place. Wait a minute, Henk Berendrecht just republished this again in 2020, so it's been double republished. Okay, let's go back up. So, okay, this is those reviews. All right, specific research here. A generalized Kleene-Rossa paradox for systems containing the combinator K. Oh no, this isn't the same thing either. This isn't, and by the way, do I pick up that? Should I keep that purple thing along with this or not?
That purple tag actually went to the one that you moved, I believe. The purple tags go with the ones that is below it.
Oh, okay, so I messed this up. Okay, but in any case, I need to move this one as well. Because this is also part of, I'm going to put this in a buffer over here. This is part of combinatory logic, not, I'm going to have to move these down. This is not what I thought it was. I mean, the title was misleading. I'll be pointing out that combinators have nothing to do with combinatorics. Oh, gee, yeah, I'm sorry. People are jumping into the middle of a horrifyingly complicated thing. I wrote several pieces about combinators. There's one of them. At the end of last year, you can look on my, maybe somebody can post in the chat the URLs for these things, and that will explain what combinators are. But if I start talking about that, I'm going to go way off track. I was kind of assuming This is what I get for doing my working meeting live and in public here. So combinators are, yeah, this is, they're a basis for computation that was invented in 1920, and that has been quite difficult to understand and has sort of threaded through the history of things like lambda calculus and so on as as a very formally good thing to study, but very difficult to understand. And so I was kind of tackling that again and could understand a bunch of new stuff based on kind of things that we figured out in recent times, particularly with the physics project, but I wanted to do the history project of going through and understanding what the history of the field had been, and so here we are looking at combinatory logic. So combinators are these things, S and K combinators, that are sort of bases for computation. Combinatory logic is about kind of relations that hold about S and K combinators, trying to imitate relations that hold about logical expressions. And it has a slightly different purpose than the original combinator calculation or computational system. And so I'm trying to understand, let's see. I think that's that, okay. Why is there, oh, so that's another simple combinatory calculi Mr. Smith or Ms. Sabunin has in 1973, and then 1975. Okay. Third class of combinatory calculi. There's no Markov algorithm. Oh boy, it is hard to tell exactly what's going on in these. Oh boy. Let's see whether any of these get a little bit more obvious. Okay. What the heck is that? Seems like all the ones that I'm most interested in are the ones that have the purple things next to them that mean we don't have a copy of them yet. I wonder what on earth that one means. I don't know. Okay, that one I understand what that is. Now this one here, do we think we have a copy of that one there? Statman, 1989. Statman. The word problem. There we go. Okay, so this is a typical. Okay, this finally is an example of a specific study of the thing that I thought this section was supposed to be about. Let's see. Oh boy. Okay, so that one is one that is definitely belongs in this section. This one also. So I'm just trying to understand some of these other ones. Okay, so how should I indicate these? I'm going to put a star next to the one that seemed like they're actually in the right section. Okay, this one, Fokker 1992. Where's McCune 1991? And oh, I see. Fokker 1989. Oh, we have that. Yes, I see it sorted differently. The systematic construction of a one combinator basis. Yes, that's relevant. Oh, my friend Simon Peyton Jones shows up there. One of the creators of Haskell was involved in the combinator business at some point. On Sets of Solutions to Combinator Equations by Rick Statman. Okay, Sets of Solutions here, 1989. Combinator equations. Family of combinator equations is closed down to beta conversion. Boy, these papers do not make themselves easy to understand. Ah, and then it's over. Okay, what is he doing here? Okay, these are combinators. Well, solution sets to the combinator equations. Okay, they're mentioning both Plotkin and this Bowman-Dasani. Let's take a look. What was the Plotkin? Oh, that's referring to Hank Barendrecht's textbook. Okay, do you think we have this one? Bowman, whatever it is. Let me pull this out in case we don't have it. I love the way that it converted when I copied Bohm O with an umlaut, converted to an A for some strange reason. Okay, there is no hypercurrent SK combinator. Where is that one? 1991.
It's from 91, yeah.
Okay. What does that even mean? Okay, well, this is at least relevant. This is, I assume we have this one, by the way, Klopp on combinatory reduction systems. That should be in the overview section. Okay. The absence and presence of fixed point combinators by some long-time automated theorem proving people. Let me see. There's a list of combinators, dandy. Now, did they actually do anything here? Searching, did they find anything? Oh, come on. Do we have this paper? Apparently not, from 1987. That should have been in this section if it was. Oh, do I need to? Okay. Well, my experience with these characters was not good, so I'm not surprised they didn't actually do anything here. Okay, full results are reported in 11. A preliminary report. So what happened to that preliminary report, I wonder? And why did they not put that in this paper? These guys were very squiggly. Very squiggly. They had a habit of they're neither of them is alive anymore, but they had a habit of kind of, I think, as I discovered, of foraging for things that they could claim they'd done with their automated theorem proving system. Not really a good situation. Still, we are providing a bibliography, so we will include it despite the personal flaws of those individuals. Okay, systematic construction of a one combinator basis for lambda terms. This seems relevant. Okay, that's relevant and lovely. Okay. It even looks like a, see, the thing is also, some of these papers are much better than others. I mean, that's a nice clean paper. Why are they referring to Simon Peyton Jones, who we don't have in our bibliography here? But everybody seems to be referring to this. Let's take a look. What are they actually saying? Because I thought that was not so much. Oh, combinators are important for the implementation of functional programming languages. So hopefully we have that in the section on we should obviously have that.
We have a reference to Jones in the implementation of combinators section.
Okay, great. I think in the British tradition he would go by Peyton Jones. Okay, how to decide the lark. Springer, 1993. Well, this seems highly relevant. Oh boy. Okay. Yes, that one is highly relevant. Okay, the kernel strategy and its use in theorem proving. Why does he say that? That's just ridiculous. Berendrecht defines combinatory logic as an equational system. Excuse me, that was defined by Schoenfinkel like 60 years earlier. Why does he say that? So this is, okay, it's talking about how great Otter is. Okay, boy, this is a long paper. Let me see what happens in it. Brief introduction to combinatory logic. Why doesn't he say where it came from? More than 60 years ago, the study of combinatory logic commenced. It arrived like on a meteorite. I think there was a pattern here. I don't understand why he says Berendrecht defines this. This was absolutely not, I mean, this was defined by Schoenfinkel in 1920. Weird. Weird. What is he doing? Why is he doing that? This is some kind of credit game, as academics are wont to play, but I don't know exactly what it is.
I think you can define combinatorial logic as a model that satisfies these equations. I'm not sure that this was the original intent of Schönwinkel. So
I see. So this is then the study of, but how did it commence? I mean,
yeah, that clearly deserves
kind of
reference to
bizarre.
Schönwinkel.
Okay, all right. Well, maybe, okay, so maybe the fact that there's an equal sign here rather than a transformation.
Yes.
But let's see what these guys actually did. Boy, they were squigglers, all right. I mean, boy, this is interesting. They were, wow. So wait a minute. They said, after all this stuff, they repeated the result that Statman had already found. Great. I believe that the only discovery made with automated theorem proving that was unexpected ever in the history of the field is what I did with Boolean algebra in the year 2000. And we'll see whether they had any unexpected discovery, because here they didn't have an unexpected discovery. They rediscovered what Statman had already discovered.
But the next sentence talks about new fixed point combinators they discovered.
Well, and then they reference 12. Let's find out what 12 is. Okay.
That's probably
That's 1987.
The source of the of those experiments.
Yeah, but what is this? I think these guys had a pattern where they got something from somebody else. They then wrote a web of papers about it themselves and referred only to themselves. I think that is their pattern. I think we're seeing that in this case. Very interesting. It's very interesting. I saw them try to do that in some other cases. I didn't know they'd done that here as well. It's very interesting. And academic behavior. Very interesting. Okay, kernel strategy, what's going on here? So let's see whether anything happens here. Okay, contributions to combinatory logic. Answering question 5 in detail. The question was first answered by Statman, but they're going to answer it in detail. Sigh. Boy, maybe I shouldn't do this. This is terrible. We're gonna find all the, by actually going through and trying to trace through these actual academic papers, we're gonna find out all the squigglery that these academics have done. It's all right. There are plenty of academics who don't squiggle. I think these ones were top squigglers. Okay, well, so they've got lots of questions. They've got conjectures. Do they have any answers? Oh, we got to the end. Logicians consider that many of the questions focusing on fixed point property substantial challenge. This is why I get, I don't know, I get squeamish about making bibliographies, because I think this paper is looks kind of lame. At best, lame. What was the date of this? 1993. So this is 5 years after the beginning of Mathematica. Well, I'm distinctly not impressed, but it is relevant according to the definition of what of this section. Okay, some examples of non-existent combinators. I'm getting kind of squeamish about this, this bibliography. Maybe we should just list with some criterion all of these papers and not try to, oh boy, yeah. Okay, let's look at this. We have all met interesting combinators. This is first sentence. That's a good start. Fixed point combinators, universal generators, okay, recurrent combinators. Where's the result? Okay, various people are pointing out, asking, what do I mean by a squiggler? I mean somebody whose ethical standards are not up to my level, in part. And Epi is pointing out it is part of the history, even if there are squigglers. Well, that's true. I think, yeah, I mean, this whole business about how academia works and, what should refer to what and how does it work. As far as I'm concerned, the number one issue is if people actually do know about something and, pretend otherwise, that's clearly wrong. The question of going back and finding, did somebody discover this 50 years earlier? That's a lot of work and you might not succeed. And it might be the case that the person sort of discovered it, but you just couldn't understand it well enough, so you didn't know, and so on. But it's a very different thing if you actually know and you try and hide it. And I'm afraid that would be my definition of a squiggler. I mean, it's funny in these fields, that there's some I mean, this field is not a simple field, unfortunately. Some papers are very concrete. Some are very, let me see what this is. And Roman, if you're understanding what some of these people are on about, please speak up, because I mean, this looks like a definite kind of, this is a, commentary reduction thing that looks like it is relevant to this section, which is good. Okay, next one, in Trilogia. Non-existent Statman's double combinator does not exist indeed. Okay, fine. That absolutely satisfies the requirements of this section. It's a specific result about combinators. Preliminary investigation of random SKI combinator trees. Okay, that seems like a relevant topic. Although it might be that should go in a different section.
Looks interesting.
Yeah. I kind of think I worked these kinds of things out too, but this looks like a perfectly fine contribution. Okay, however, I believe it should go in the section that I have on meta. Well, I don't know. I have a section about meta programming in which I had a bunch of things. So that one maybe, it's just, oh gosh, I don't know how to do this. That maybe goes in the meta programming section. Okay, this one we know this paper. This is a fine paper about the S combinator, interesting result. Okay, Probst. How to normalize the J combinator. These reduction rules were given by Rosser in 1935. Hey, I wonder whether we have that paper. Oh, I don't think we have this paper. That's one of the original papers. That's Rosser a mathematical logic without variables. Okay, that one we should have. And unfortunately, he probably doesn't call them combinators.
We do have something from Rosser in 1935. What was the name of the paper you're looking for?
Hold on, let me just, it was something like a logic without, a mathematical logic without variables.
Yeah, that one is cited. You have it in Combinatory Logic right now.
Great. I just stored this in SW Notes 3. Okay, all right, great. I can remove that there, thank you. Okay. Okay, how to normalize the J looks fine. Molecular Combinator Reference Manual. This report contains in summary form definitions, schematic reactions, equivalences of all combinators. So let's just, well, this looks perfectly interesting. Kind of nice, actually. Cool. Okay. Okay. Well, that looks fine and relevant. Flattening combinators surviving without parentheses. That's just weird. What on earth is this? This is saying you can, actually, it's kind of interesting. You can write any expression. What it's saying is you can write an expression using combinators without any parentheses if you introduce new basic combinators. It's kind of an interesting result. Okay, so that's an example of one where the abstract is useful, but by the way, I think that the theoretical pearls should be removed from that title there because I think that's just a section title of Journal of Functional Programming. Okay, partial combinatory logic. See, one of the things that's confusing is some of these are about combinatory logic where you're dealing with equalities, and some of them are about transformations of combinators. Closely related, but not quite the same thing. Oh, what is all this stuff? Partial combinatory algebra. Roman, I think you've talked about those. Maybe not. See, the problem is that this stuff does segue into the whole theory of lambda calculus, which is, okay, I don't understand this paper. I don't know what this is about. Let's try. Introduce an intersection typing system for combinatory logic. I don't understand this paper.
It seems to be about typed lambda calculus.
But why does it have combinators at the beginning?
I mean, you could do the same thing in combinators as in lambda calculus.
With types?
Well, I mean, I'm not the expert on this field, but
conditional partial combinatory algebras. I have never heard of that. I've heard of the two people who created it, but I don't know what it is.
no, I'm not familiar with it either. So.
Partial combinatory algebra. Well, I think this needs to get moved into a different section. I don't know where this goes. This is some kind of, I mean, maybe we need a section on something like, you know, extensions of combinators. Maybe that's the right thing to do. Where all these things which are various kinds of things can be put. Matthew, okay. Is this about combinators? It's lovely, but example of combinators. Not sure if this quite, I mean, it is interesting. I think this goes, I think we should move this to the meta programming section. Okay, the optimal fixed point combinator. General theory of fixed point combinators. Okay. Well, I don't see an actual combinator in sight. This is type theory. Parmenides is saying here that only type theories have clear algebras. Untyped, only partial algebras work. Okay. I don't know what this is. I don't know what this is. Something in OCaml. I am pretty severely confused here. Why is it even called combinators? Well, at the very least, this is about programming with combinators, so that should go into that section. Okay, this one, we know that paper, and that is relevant. Checking the linear time, that sounds interesting, if an S term normalizes. The papers are very short. What is this? Do we have this paper? Dana Scott on some philosophical issues concerning theories of combinators. Do we have that one?
I'm checking now, 1 second.
Okay.
Yes, we do.
Oh, we do. Okay, great. Which section is that in?
Right now it's under other.
Okay. I wonder if we have this person's dissertation or whether we want it. You probably can't get copies of it, so it's not that useful. And this is a paper by the same person, so it's probably combinatory logic and S terms. I mean, I'm going to put this in here just because for completeness, but I don't think we're going to be able to get it. And there seems to be another one. What is that word? Unendlich. Roman or Hatem.
Which one? Sorry, can you highlight?
Yeah.
That's infinite, means
Infinite
not-
reduction in combinatory logic.
right, indeed.
Okay, thank you. Okay. Okay, anyway, that's a fine paper that seems relevant to us here. Asymptotic properties of combinatory logic. Bend. Random combinatory logic terms. You know, I think we should have a section on random combinators and just put these ones into that section, because I think that it's sort of interesting and it's easy to distinguish those ones from the other ones. So that goes there, and this one here goes there. Okay, and I want to review again. Okay, now let's go to patterns in combinator evolution. Oh, that's in our own journal. This is again random combinators, I guess. I think that's fair to put that into random combinators. That was about specific combinators. Okay, let's look through this section again and see whether we can clean it up a bit. So this is about a specific combinator, the Turing paper. So that's fine. This one we say we don't have a copy of, Sabunin, right?
That's correct. Sorry.
I'm pretty sure that's combinatory logic, not combinator expressions. So let's put that in combinatory logic there.
And then that same author wrote the next two, so I don't know if they're going to fall in the same category. Yeah.
Yep, they're the same. Okay, combinator operations. Did we get, I'm sorry, I forgot that one, Meredith. Theorems on combinator operations. Well, this is about actual evaluation of combinators, so it belongs in this section. Okay, we don't know about this one because we can't find it. So that's a question mark, question mark. Note on the S combinator, these are all good. This is relevant even though I don't like it. Okay, all right, that's good. Okay, I think we're on to, okay, those are about specific combinators. And okay, so combinatory logic, this is a whole giant pool of stuff, which I have to say I don't actually care that much about. And I mean, I think it's a version of this that I think is the wrong approach. But boy, Curry wrote 1,000 papers about this probably. Functionality in combinatory logic. First, properties of functionality in combinatory logic. Great.
So then when you see that also cited, that refers to the one right below that tag.
Right, this thing here. Right.
Mhm.
Do we have, let's see, you put Quine up here. Let's look at what Quine actually said.
For the ones that are cited in 2 categories, I put the paper in both folders.
Okay, thank you. A system of logistic, 1934. That's when logic was still called logistic. Oh boy. Okay, it's the device of constructing relations as unitary operators. This is currying. My present concern is to point out that Schoenfinkel's explanation of relations as unitary operators is gratuitous. Okay, so he doesn't need to do currying, Quine is saying. Huh. Huh. Well. Parmenides is saying, Dana can tell me about algebras for lambda calculus and combinators. Yes, he worked on models of lambda calculus, and I have asked him about them multiple times. And he usually says, oh, it's not worth understanding that. So that's always put me off. But I think he might be wrong. That isn't worth understanding. Okay. Well, this is sort of somewhat relevant, but I think it's not really a foundational document. It's probably, okay, this should only be in this section, I think, in the combinatory logic section. It's not that foundational. It's kind of a detail. Okay, endless things from Curry. So I wonder whether we should have this section on extensions or whether there's so many extensions. I mean, I think Curry had many different extensions himself. Let's take a look at that one there. Combinatory logic with discriminators. Normal combinators are investigated by Curry as taking functions, taking combinations of symbols. Combinators cannot take account of their arguments. This sounds like a type theory story. Oh, or is it a pattern matching story? It's not unrelated. The second application of a combinatory logic is in formulating a symbolism to represent the functioning of a mechanical device. Combinators can be employed, for example, to represent sequential circuits. As I will show below, they can also be used to represent the function of a digital computer. You don't say. You don't say. Oh boy. In order to model a Turing machine. Great. Preliminary results concerning combinatory logic with discriminators. Okay, what is a discriminator? Roman, did you understand this? Anybody else understand this, what this is?
No, I don't.
Maybe it'll be in a footnote. Always a good place to put your key definition. Oh, come on, where is it? Combinatory numbers. Okay, that's church numerals. Discriminators. Okay, combinators, but not pure combinators. The basic discriminator is Z. Oh, I see.
So that's pattern matching. They
Yes.
peak at their arguments.
Right. Okay, where should we put this? This does not belong in combinatory logic. I think it might belong up in the section on explicit. Well, maybe it's extensions. I guess it goes in the extensions of combinators. Where did I put that? Extensions of combinators. Okay. Certain properties of Schoenfinkel-Curry combinators, Kozichev. Oh.
So that is not the full
Yeah, I see
paper,
that.
obviously. I think it is actually a review by H.B. Curry.
Wow. What does this mean? What? Consistent expansions. Well, at least we've got our friend Mr. Emil Post being mentioned here. Post inconsistency, that being Emil Post, I think, rather than after. But there was nobody named Cut. Okay, I don't understand this one. Okay, simplification of combinatory logic by Goodman. Let's take a look at that one. Suppose the mathematician is working on a specific problem at AB. If either A or B is not a constant, then you must solve the corresponding subproblem. What? Okay. Anybody got any idea what this is about? I love the way that these so often say the theory which results from adding such principle will be the subject of a later paper, and then I'm sure that paper doesn't exist. I don't know what this paper is about. Oh boy. Okay, well, actually, this is fun because I like okay, we imagine an idealized mathematician. At any given time, mathematician is working on some problem. Okay. I like the idea of thinking about an idealized mathematician. Okay. Okay, what on earth is this? Why does it have to do with combinators? I think we're putting this in the section on extensions of combinators, even though it says it's a simplification. Okay, consistent extensions of pure combinatory logic. That's the thing we just were looking at, isn't it? That's the same abstract we just saw. Oh, did I look at the wrong one? Was I looking at, oh, you had the 73, yeah, okay. Okay, a little bit unclear. Generalized Pliny-Rossa paradox for a system containing the combinator K. From Martin Bunder, 1973. Oh boy, well, these papers at least are short. You got to give them that. It's just over a page. I couldn't tell what was happening in that paper. But it is related to combinatory logic, that I can tell. Parentheses, it must be parentheses. Yeah.
Sorry, my bad.
No problem. Unique readability is lost by omitting the parentheses. Boy, there's a... Ay, 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 ay. Well, this is a rather trivial thing. What do we do with this document? I mean, this is... What does this count as? It's some kind of notational... Well, okay, hold on. We got another category then, I think. That's purely notational. And so is the one about flattening combinators that we had up above. Where was that? Oh, and actually that one by Quine is also notational. And the one about, what was it? Flattening, surviving without parentheses, that is also notational. Abstraction problems in combinatory logic. A compositive approach. Bracket abstraction, okay. Turner's algorithms. This should, I think, go in the section on explicit combinator expressions. This is about combinator reduction, but it goes in the section there. Okay, what's the best way to do this? I'm going to put this in. I mean, okay, we'll go back. We'll go back to the Nielsen one. Okay, I'm going to put this in. This will not be in order.
I can go back through and fix the ordering later.
Functional completeness of mixed lambda calculus and combinatory, whatever. This is a kind of programming with combinators thing. Okay, that should go in programming with combinators. Maybe I had a section already here, but okay, Barondect. I'm still fuming a little bit about those theorem-proving bandits that we encountered a little earlier in the hills. It's kind of the opposite of yeah, anyway. I like that these people are using capital Xi. It's my favorite notational weird letter, but it doesn't help me understand what on earth they're doing. Okay, let's see. Okay, so this is an extension of combinatory logic, but I don't know how much of an extension. Boy, I think we should consider, I don't know, I think I'll leave it in the section on combinatory logic. Some results on combinators in the system TRC. Type respecting combinators. I think, well, this is combinatory logic, that is for sure. Boy. And they reference the otters. Question is, if they used Mathematica, would they reference it? The answer is, maybe one needs to be a bandit if one wants to get one's work referenced like that, if one cares. Okay, on the word problem for combinators. I think that should go in the section on explicit things. It looks like Rick Statman has written an awful lot of stuff about explicit stuff about combinators. Okay, an untyped higher order logic with the Y combinator. Boy, in 2007, that's about this. Yeah, that's around the same time that the Y Combinator accelerator program started. Different Y Combinator. What is all this? Well, at least it mentions the Y Combinator, okay. Conclusions. Whether the logic of this paper turns out to be practically useful remains to be seen. Okay. Untyped higher order logic. Should this go in generalizations? I kind of think so. I don't don't think it's relevant directly to the theory of combinatory logic. Fixed point combinators as fixed points of higher order point generators. Any idea what this is about? Anybody? No. Fixed point generators. Well, this is, anyway, this is in the section. This is in the wrong section. That should be again in that section on wait a minute, is this the section we just got to? Did I just put that back in the same place?
I think you maybe copied more than just one. I couldn't tell though. It's moving fast.
I think I copied it back to the same place I took it from. Okay, combinator constructions. I wonder if those guys. There may be some other things that should go in there, because there was one where there was combinator trees. Where did I have it? Yes, this one here. That should go in combinator constructions. Okay, so this a basis result in combinatory logic. I think we have to put this in the section on explicit combinators, probably. Let's look at what this one is. Two variables are not enough. Oh, that's a nice result. That's a nice result. That's relevant to the S Combinator project. I wonder whether it's, okay, so those two will go up here. Oh my. Oh my. How do we distinguish these from all this other stuff? Oh my. The bandits are here again. Let's see how they did the next time round. What? Boy. Yeah, we should wrap up soon. This is unfortunately not going as well as I'd hoped by a long shot. I just don't understand how they managed to reprove the same things over and over again. Why don't they figure out something new? Huh? Well, this probably shouldn't be in the section on combinator reduction because it really isn't any different from some of these other pieces. Oh, dear. Unfortunately, there's a lot of work to do here to clean this up. I'm beginning to be a bit pessimistic. That one has to go in the random whatever section. Well, I mean, I put these in these sections just based on their titles. That's not published. They sent that to us privately.
It is in the Dropbox folder as well, the one that they sent to you. Just
Yeah,
no
I know.
link for
I
it.
know. Okay, let's just look through what else we have here. Models of combinatory logic. Okay, so there should be a basic paper by Dana Scott that isn't here, probably because it talks about lambda calculus instead. Maybe Roman, maybe you know what that paper is.
Oh, no. I mean, if you go to the second, the one by Park, there's probably the references.
We're out of luck.
No
Dana Scott's
references.
paper, there's no reference. I think there was some weird thing. I think Dana didn't publish this for like 20 years or something.
We do have a couple of papers by Scott. I just don't know if I have the one you're looking for.
Okay. Well, let's go down to the other section just for, okay, combinatory grammars. I now understand what those are, at least. That's a good start. Relation to lambda calculus. Implementations. Okay, there we've got Simon Peyton-Jones, although we don't have his book, Introduction to Functional Programming or something, which it seems like is what people are referring to. And I think I did find those pages and they were a nice, clean description of combinators. Okay, so this is a lot of detailed stuff about, that has to be misspelled. Can you check that one? I'm sure that's Simon Peyton-Jones again.
Yeah, it's probably a typo. Let me check really fast.
I don't want to like give him a Y and then it turns out it's a completely different person. and we just confuse everything. Okay, that I think is a repeat of the same guy. Well, at least it's a serial publication of the same thing.
That one that you just mentioned is Peyton Jones. I just missed the Y. Sorry about that.
Okay. Okay. Okay, this is various evolving combinator people. That's a different Scott. Oh, other. Okay, here we go. There's Dana Scott. Okay, other. I want to see what that was about. I see. This is why Dana always signs email and has done for like as long as he's been sending email, with himself always in capital letters. Okay, interesting. Well, I don't really understand what this paper is about. Oh dear. No, I don't understand it. Let's see if the other Dana Scott paper. Oh, okay, 75. That sounds like an interesting topic. What does this mean, though? Okay. Combinators appear in many theories. They're not going to be an ultimate foundation, either for logic or a theory of computation. I think that's not quite fair. Okay. Okay, this looks like useful paper. All the stuff we know. Stable versus unstable. Okay, whatever. That's, well, I don't think it's that vague. No. Well, this was 1975, so gets some points for it being a long time ago. Oh, this is a useful paper, at least. Let's see. That's an interesting idea being suggested on the live stream that we put this in the data repository, this bibliography. Yeah, it's not a bad idea, particularly if it was more computable, but oh, we're about to come to the end here of this well, this paper really isn't about combinators. It's fine and dandy, but it's not about combinators. It's about lots of other things. Spaces with Combinators, 1993. Well, it does seem to be about combinators of the kind that we know. It says complex such and such in Bulgaria, but I assume that's not complex systems. That's a complex as in a place where things have been brought together. Okay, can't tell what that is really. Have a quick look at these. Combinatory. Well, this looks relevant, maybe. Okay, fine. That's what we're just looking at. Martin Loff. Well, that's a well-known, at least topic. I don't know if this is the original paper of that topic. Dijkstra has referred to the difference between computer science and computing science. I think that distinction has been lost. Again, doesn't seem to have much to do with combinators. Oh boy, okay. Well, this did not go as well as I'd hoped. We need to wrap up in a moment here. Just to make some comments for anybody who's survived on this live stream, and I apologize for this being just the most, well, first of all, I have to thank people who put together all these abstracts on our team. This is fine work. This stuff is just horrifying mess. Oh my. And yes, there's people on live stream commenting, this is the world of academia. I mean, oh my. You know, many of these papers are pretty hard to understand. And I don't think that's just me. It's remarkable. In all the papers we've looked at, there have been almost no diagrams or pictures. Sometimes the notation is fairly clean. Sometimes the notation is just like, you know, you have to go through many layers of understanding to even know what on earth the notation means. This is why I'm a big fan of click to copy stuff, because it keeps you honest, so to speak. Every single picture you make and the things you write, there's got to be code behind it that you can actually run. And if you want to understand how the code works, you can just go look at the documentation for the code. And it isn't, it's not one of these things where you might understand the definition, you might not. I think we didn't look so much at the more applications-oriented areas here, which might have been possibly a little bit more, well, I don't know. Yeah, I mean, unfortunately, in a lot of these documents get written for some academic purpose. It's not clear anybody ever reads them. It's kind of a weird business. And it has a certain, you kind of hope that if you write, if enough papers are written, somehow eventually the frontiers of something will be moved forward. But what we do see also here is that there's a fairly fixed set of names that show up over and over again. And and a bad thing often is that when there's a name that isn't, part of the usual crowd, sometimes that paper just gets completely ignored. Yeah. It's a comment from Epi on a live stream. If I tried to put code through a pull request that was unclear like these papers, I would be laughed at and the code rejected. Yeah, well, right. And academia has peer review, but as we can see from the communities here, this is a very closed community. And I'm sure that in the world of peer review, it's everybody accepts each other's papers and they publish in some fixed set of journals. And, nobody comes out behind, so to speak, because unless it's some poor, unsuspecting person who subscribes to that journal, believing that it's sort of peer review by the whole world, when it isn't really. Yeah, it's a mess. But yeah, I mean, this area to be for those interested. I mean, there are areas of academic work that are both easier to understand. I mean, this is definitely one of the harder to understand areas. Although there are areas in pure mathematics that are at least as hard to understand as this. And this is, one thing that's interesting about this area is that there's a lot of interstitial stuff somewhere between logic, mathematics, computer science. And so one of the things that probably makes this more difficult is that the conventions, if you pick a particular field, like, I don't know, some area of pure mathematics, there are more definite conventions about what papers should look like, and that probably helps in understandability, because a bunch of these papers were really written in rather different ways, and didn't help understandability here. But I'm kind of disappointed because I'd hoped that in a limited number of hours it would be possible to get through this whole list, and I'm now feeling a bit daunted at the size of this project. I've never done a bibliography like this. So actually, I have. I did one once for cellular automata, but that was in 1985, and I had looked at, in detail at every single paper that had been written, and I had sort of lovingly found them in the printed Science Citation Index back around 1981 or so. This is a little different. I don't know this field as well. And I mean, there are basically 900 source papers here. And who knows whether that's even complete, because those are the ones that mention combinators somewhere in a variety of different sources. Well, all right, interesting. Well, I think we have to regroup and try and figure out what to do. I would say we could just put out the version of this that we have right now, and maybe other people could help us, but I think this is a really complicated task. And I'm a little bit wondering what the right thing to do is in terms of the bibliography that we might produce, because, I mean, this is already useful because, I certainly didn't know a lot of the material that's in here is going in different directions from the ones I knew people had gone in. So that's useful. Whether it's, I mean, in some sense, and I hate to sound cynical about this, but academics are always saying, give us references, give us references. Well, this exercise of trying to make this bibliography, and by the way, reality check for people, most academic citations in modern times, it is my impression that the people who cite things often haven't read what they cite. And certainly there are famous cases where page number errors have propagated through endless citations and recitations of things, because the people who are writing the actual papers never read the citations again, never read the actual documents. They just cited it because somebody else had cited it, so to speak. And so this concept that it's one of these things that I think is a crutch. I mean, I'm much bigger believer in terms of understanding the lineage of ideas and actually trying to figure out and write down the history of ideas, which I do quite a bit of, which is hard work. And this is sort of part of the raw material for that. But this is, for example, if I was writing a history of the field of combinators, I would have to go through all these documents. But I think I would find that there are a lot of tentacles, a lot of spurs, which weren't in the mainstream, where somebody, wrote this master's thesis about this and then stopped working in the field, and that's it. That's the end of the line on that, and nobody ever noticed it before. And I'm sort of the first person who's ever dug it out of some bibliographic database. So it's but yeah, I was, when I wrote the New Kind of Science book, I had kind of an interesting point of view, which was that was coming out in the year 2002. And I thought we were at the edge of where people would no longer give kind of journal name, page number type citations, because I thought it would be the case that anything you care about finding, given the name of the author and given a keyword, you could find it better on the web by searching than you could find it by looking, by leafing through the pages, as I had done many times, of actual physical journals, and find, volume such and such, page such and such, and realize that probably nobody has ever opened that page of that journal on that university library's shelf before. But I thought it was a transition time when people would just be, look, let's just use web search. You've got the name of an author, you got a keyword, you can just find not just the one paper, but everything else that's relevant in some fraction of a second. And so I concentrated in New Kind of Science book on actually writing the narrative histories of things, which took a lot of work. And lots of academics were like, oh, no, you should have given citations, you should have given references, including page numbers, including whatever. And it's like, it seemed wrong, but but I guess the world still isn't that modern. Let's see. RBS is commenting, you should check out paper by Gibbert on functional programming with combinators. We do have that paper. Okay, now I'm now motivated. Let me just look, and then we should really wrap up here. Programming with combinators in programming. Let's see here. Gibbert, 1987, is that right? Okay. Well, at least I can understand the notation here. That's a good start. He says, famous last words. Okay. JAM, what is this? Huh. Yeah, this whole business about execution graphs and combinators is interesting, and I think I need to understand that better. I mean, the fact is that combinators, if you are prepared to turn your program into a combinator expression, there are all sorts of interesting things that can be done with it. The only problem is that humans are really badly equipped to understand combinator expressions. Huh, okay, well, these ones we certainly know. Skim was done by Arthur Norman and my friend Philip Gladstone and some other people, and that's David Turner's work. Well, there are probably some interesting things here. So far, there is no parallel reduction machine that uses combinators to implement symbolic computations. No parallel reduction machine. It looked like there was another paper by the same chap. J machine, functional programming with combinators. Okay.
I'm wondering if they're, you should open it up maybe if you want to see for sure, but they have very similar titles. I wonder if it's just a reprint in a different journal.
No, it's just academia. I think I think
They are
this is
different.
different.
Well, the other one is a conference paper.
Oh, okay.
But this seems to have a bunch of other things. The J machine users manual. Now, is that related to J and APL functional programming? I wonder. There's actually even more papers that seem to have almost exactly the same title. Well, now I'm curious. Obviously, we can figure out. Okay. That's strange. This person published in the years 1985 to 1987, and then nothing after that I can find here. Well, I suppose that's the kind of thing you would find for me too. I didn't publish an academic paper since 1986, except that I've been sort of publishing some of these papers about the physics project, and sort of academically. Okay, well, that was a surprisingly deep dive into kind of the infrastructure of academia. We should wrap up for now, and I think I'm supposed to do another live stream about a completely different and more yes, I'm looking at a design review of some Wolfram language functionality. Okay, that will be a completely different kind of thing. All right, well, thanks all for being here, and yeah.